let's miss this by. This will be how to transform the exponential function. So the main way we transform it is by translating it. The power moves it right and left, and the c value moves it up and down. In general, positive c's up, negative c's down. Positive h is left, negative h is right. If you notice in the equation, it's a minus sign. So where things get interesting is that, remember, plus goes left, minus goes right. And the main thing we look at moving is the y-intercept. Let's look y. So let's do one case where there is no horizontal shift and one case where there is. So if we get y equals 2, 5 to the x. Right now the y-intercept is 0, 2. By me adding, let's say 7 to it, the new y-intercept will become 9. Let's see why. So remember, the y-intercept on x equals 0. So 2 times 5 to the 0 plus 7. 2 times 1 plus 7, because 5 to the 0 is 1. 2 times 1 is 2. 2 plus 7 is 9. So the shortcut, without anything as our power, you just add these two numbers. So 2 and 7 is 9. That's an example where there's just a horizontal shift. And we'll do it in 2 ways. Okay. So we can do this as 4 to the third power x plus 2. And you can do this the long way, x equals 0. 4 times 3 to the 0 plus 2 power. 4 times 3 squared. 4 times 9 is 36. And I just shifted the y-intercept to 36. Another way to look at it is you could break up 3x plus 2 into 3 squared times 3 to the x. And then if you multiply that by 4, 4 times 3 squared is 36. It's another way of looking at it. Okay, let's do an example where we're shifting left to find the y-intercept, and then to combine both rules. And then we'll look at the graph. So y equals 5, 5, x to the minus 4. And you can rewrite it as 5 times 5 to the 0 minus 4 power, or 5 times 5 to the negative 4th power. 5 to the negative 4 power is 625. So 5 to the 1 over 625, or 5 over 625, which simplifies to 1 over 125. Another way to approach this is to rewrite it as 5 times 5 to the x, or 5 to the 4th. And then 5 over 5 to the 4th is 5 to the x over 5 to the 3rd power. And that's 1 over 125 times 5 to the x. So our y-intercept in this case is 0, 1 over 125. And you notice how the y-intercept changes every single time we either try to shift to right or left. And you could treat it by plugging in 0, or you could treat it by simplifying and separating to just get the a value in front. Now let's do both rules together. We'll show how both rules affect, then we'll look at some graphs, and then we'll wrap this up. Let's look at one positive case and one negative case. Y equals 2x plus 3 plus 5. And we'll multiply, let's add 4 in front. In this case, the y-intercept would be, and I'd recommend literally plugging in 0. There's no faster way of doing this. So 0 plus 3 is 3. 2 to the third power is 8. 4 times 8 is 32. 32 plus 5 is 37. And you do the same thing if it was negative. That would just make the multiplication a little different, and that would decrease it. And flip the graph over. Because if this was negative, and that's what we'll wrap up, I'll flip the graph over, make you have negative 4 times 8 plus 5, which would be negative 32 plus 5, which is negative 27, to be 0. Negative 27 is your y-intercept, here will be 0, 37. Let's look at the graph of both of these and watch what happens. Let's do 4, 2x plus 5. You'll notice the whole graph shifted up 5. Shift up to 9. 4 plus 5 is 9. In a different video, we'll look at the value it's always above, known as the asymptote. And that's what this number at the end, 5, is literally changing. It's changing the asymptote. It's always above 0. If I add 5, it's always above 5. Subtract 5, it's always above negative 5. And if I really want to shift it more, and now to 9, I can shift it more by adding more to the range all the way be up at 36. So 2 to the third power is 8. 8 times 4 is 32, so 37. All the way up there at 37. If I make it negative, just shift down to 27 and put the whole graph over. Negative 7. That's how you transform an exponential function. More on the asymptote in a later video. This is Spy signing off.